Hello world, it's Siraj, and I've built an app called Doctor Source. It's basically a doctor in your pocket. Let me show you a demo of how this works. Once I log into this app, what it's going to let you do is talk to an automated doctor that will give you a medical diagnosis and a treatment plan automatically. It's an on-demand medical diagnostic and treatment plan tool. Let me show you how this works by giving you a short demo. Here we go. My head hurts after listening to music loudly for 3 hours. Now it's going to respond, asking any follow-up questions. Any other symptoms or medications you take? No, just a slight pain on my forehead. You have a migraine, rest, take aspirin, and drink 8 ounces of water. That's the result. All right, so what it did was it took my query and then it input it to a model called BioBERT, which I'll explain in a second, and then it output a diagnosis. Now, let me show you where I got this model from before anything else. Just take a look at this. This is super, super, super cool. You can do this yourself in the browser. You don't need a GPU or 5 of them or anything. You could just do this in the browser with this Google Colab file. I have a link to it in the video description, but you can use this and see it for yourself, right? Seeing is believing. So right here, I've got this question text. What it's done is it's loaded this model up into the cloud server that Google is hosting, and you can run inference just like this. So here's the default text. I've had chronic migraines for 4 years and they just keep getting worse. It's actually a pretty long text. It talks about all the medications this person is using and the side effects as well. But basically, the model will give back several different diagnoses, like you should see a neurologist, you might have a neck issue, etc., things like that. But let's in real time use this model, okay? So I can say I'll just make something up. My head hurts let's say my stomach hurts. My stomach hurts after eating eggs and I have a fever all of a sudden. Okay, let's just see what it says to that. And so what it's going to do is it's going to inference the model. One of the responses was an automated doctor asking for other symptoms, which we can then realize, put those back into the query, and then re-perform inference. Another one says you have severe pain. One of them says you might have a stomach ulcer. You likely have a stomach virus. Now that one looks like that's probably the one, right? It's only been 2 days, and then it gives you a treatment plan. Drink plenty of water, rest your stomach, etc., things like that. Now we can input anything, right? We could say my leg hurts after. How about my ankle? My ankle hurts after running 4 miles. I'm literally making this up. After running 4 miles and my ankle hurts after running 4 miles and I am sweaty and it hurts a lot. I don't know, it hurts a lot. Let's just see what it does. Wear some ankle support. That's one of the first treatment plans. Another one, here's a nuanced answer. It would sort of depend on how much pain you're in. If it's a minor discomfort, it could just be a flare-up from a previous injury. Ankle specifically heal awful in my experience. I'm basically reading all this disparate text. Like, we're gonna have to process this text, post-processing, to provide the user with one very clear diagnosis. But look at all this valuable data. Isn't this amazing? This is amazing. Like, this is freely available for anyone to use, and anyone can make a profitable business out of this technology, which is what I want my audience to do. I am here to help you build wealth by providing services that are impactful to other people using AI technology. That is how we take the power of AI and implement it into the lives of other people, by building sustainable businesses. Don't work for somebody else. I don't have a boss. I've never been able to have a boss. I always either quit or I get fired from any job I have. But look at me now, right? So I want you to have the same thing. So here's what I'm saying. This model is incredible. I found this model. I did not build this model myself. Of course not. I saw this model online, and what I did was I said, okay, this model right here is really interesting. Let me provide a voice interface to that model that actually provides a user, a real person with the results. So I'm going to show you how I built this in this video, all right? So that's the point of this video. How did I build this app so that you can build this as well? Now, there are 3 learning objectives from this video that you're going to learn. These are the promises. Number 1, you'll learn how BioBERT works, this model that's able to provide these diagnostics. You'll learn how to build a Flutter plugin. So Flutter, if you don't know, is a tool that allows you to build an app for both iOS and Android with the same code base. Super cool stuff. And I'm going to show you how to build a plugin for Flutter, so that you understand how these plugins work, because you're going to build a lot of them. You're going to use a lot of them. If you're going to build any kind of Flutter app, you're going to use plugins. So it's good to know how to build one. And the third is how to chain together multiple machine learning models. You know, sometimes you'll have a machine learning model, it works really well, but if you take the output of that model and you feed it to a different model, the result is going to be even better. So learning how to deal with multiple models, useful skill to have. I'll show you how to do it in this video. Okay, so those are the 3 learning objectives in this video. Yes, I'm going to wrap. This is going to be awesome. All right, so just stay tight, sit down, relax, enjoy, and watch me do my thing. Okay, so here we go. So the tools I used were, first of all, Flutter. If you don't know how Flutter works or what it is, watch my previous video called How to Build a Healthcare Startup for details on how Flutter works. The second is user account. For user accounts, I used Firebase. I keep using Firebase. I love Firebase. It easily lets you implement user sign-in and sign-up functionality, as well as provides you with a database to store any important details that a user has in the cloud. For the user interface itself, you know, I was thinking about what this looks like. What does a voice app actually look like, right? Because this is a different type of user interface design. I was actually talking with the head of Amazon's education department at Alexa about the future of voice, which was a really interesting conversation. And you'll learn about some of my learnings through this video. I'm implementing it through this. We're going to design a voice interface together. Super cool stuff. Voice is the future. And so in thinking about that, I decided to use this list view widget, which is going to help with the voice interface, which is a part of Flutter. And you'll see exactly what I mean by that. For payments, Stripe and Razorpay. We're trying to encompass as much of the globe as we can as possible. In the words of Eric Schmidt, if you build a product, you want to build it for as many people as possible. Because in the age of, to quote Naval Ravikant, in the age of infinite leverage, if you don't do it, someone else will, because they can, because that's what the internet is. It's a multiplier. It'll take any idea or thought or activity or service that you have, and it can amplify it by 100-folds, like orders of magnitude. So if you don't build something for everybody, if you just build it for a luxury small market, someone else will, and they will overpower you immediately. So we want to build this for as many people as possible. That's why, you know, I've integrated 2 payments, but the goal is to integrate many, many more, Bitcoin included. Bitcoin to the move. For voice recognition, now here's the plugin part. So there's an API, there's a native API for iOS and for Android for voice recognition. And so what we're going to do is we're going to build a plugin that accesses those APIs directly from Dart code. And of course, the AI model itself, BioBERT, which is an amazing, amazing AI model. Like, this is what I was waiting for. Like, BioBERT is awesome. Like, it just came out a few months ago. I hope that this video inspires a lot of people to take this thing and serve people with it, build some businesses, make some money with it. BioBERT is extremely exciting, okay? I'll explain how that works. Now, first of all, there's a lot of opportunities in this biomedical space, right? And we talked about some of it in my previous video, how to build a healthcare startup. Basically, these are all topics that you're seeing here, right? These are all topics that you can build a service for. But I want you to remember to think about ways that you can save these people, nurses, doctors, patients, administrators, everybody in the healthcare space. How can you save them 2 things? Time, okay, time and money. If you can save them time and money, by providing them a service where you earn money, you're golden, okay? So that's what we want to think about, time and money. That's what we can do with AI models, whether it's making the surgery process more precise, faster, you know, money, right? You're saving the doctors from lawsuits, to creating virtual nursing assistants, which reduce the need for, you know, help free up nurse time as well, right? When you have virtual nursing assistants, fraud detection saves money because there's a lot of money loss from fraud, etc. Things like that. The absolute most exciting part about biomedical technology is anything having to do with genetics or with gene editing, bioprinting, nanomedicine, synthetic biology. Oh my God, synthetic biology is so amazing. And I really wish more people loved it the way that I do. And if you don't love it yet, watch my previous podcast interview with Brian Johnson. Just search Siraj Brian Johnson on YouTube and just watch the whole thing. I love biotech, and I really hope more biotech startups start coming up, and we'll talk more about that later. But frankly, the YouTube algorithm doesn't like me promoting anything biotech related. It hurts me when I promote biotech related stuff, but I don't care. I'm gonna keep talking about it anyway. It's amazing. The profit motive isn't as apparent there yet, but it will be, and I'll show you how later. But right now we're focused on this automated doctor, one life-changing service at a time, right? So by the way, this awesome website has all of these great ideas to help you ideate on what kind of startup you can do in this space. So link to that is going to be in the notebook, which is going to be in the video description, the GitHub link. All right. So let's get to designing our app. Okay. That's the funnest part. We're going to design our app together with the whiteboard. So here we go. All right, so let's design this app. So of course we want our, standard login page, of course, you know how it is. And then we want our sign up page. So we'll have a login page and we'll have a sign up page. And of course we have our username and password field, the login button, the sign up button. The sign up button is what is going back and forth to this login, to the sign up page. And so we've got enter your username, enter your password again, just to make sure, and sign up or go back, right? Simple stuff. This is just boilerplate, reusable stuff. Nothing really intense here. We'll have our logo. Let's call this app Doctor Source, okay? And user pass, and then log in, okay? So once the user has either first signed up and then okay, by the way, I don't want to forget this. We want to add our payment functionality here as well. So we'll add our nice little Stripe payment button, and I'll add this little, mini pop-up here for CVV, the expiration date, and the name on the card, all the card details. So when they sign up, they're doing this. And let's just say, not everyone has access to quality healthcare. So I want to say that this app is not going to be better than a human, right off the, it's not going to be better than a real doctor at giving you the best diagnosis possible, but it is better than nothing. So people who can't afford healthcare, right, because it's too expensive, this is the app for them. So it's an app for the underserved. And what we can do is we can target the underserved at first, use their feedback to improve the app, what things they like, what things they don't, what's working for them, what's not. And then once it's really robust, then we can start providing it to people who already have healthcare, but they don't want to have to go to the doctor and then go through all the paperwork and all that, right? You just pull out your phone and say what your problem is, and it'll tell you what the problem is, right? So my point is that, if we're aiming for the underserved and we want to build a profitable business that can earn us some wealth, we have to charge something here. But let's keep it low. Let's say $10 a month to start, okay? $10 a month. And you can do some user research here, market research to see. This is way cheaper than going to a doctor, by the way. So $10 a month. By the way, doctors, don't worry. I know there's some doctors watching this. I love you. I respect you. I was, my parents wanted me to be a doctor. All Indian parents are like this. But, I thought, what? I'm just going to help out with this. So look, this is not going to replace doctors. This is going to help them out. I think the role of doctors in the future is going to change over time, but the need for doctors will never go away completely because there will always be a need for humans who can heal other humans. And then technology can help with that. Okay, so let's continue to go this way, right? So now that we have logged in, there's some words of wisdom for you. Now that we've logged in and signed up for this app, now it's our main screen. This is what we actually care about. So what do we want this to look like? Well, let's just say that this is the part where the user is actually going to interact with this app. So let's say it's going to start off with this, microphone thingy, right? So you type something in and it's going to perform speech to text. And we want this to be, some kind of list of all the things that you're saying and all the things the doctor is saying. So it's going to be like a back and forth where first I'll say something and it'll say, here's my text. And then the doctor will respond and then they'll say something else. And then again, I'll say something else. and then say something else until we get to that treatment plan and diagnosis plan, right? So that's what we want this to look like. So we have a button here, we have a list view, we have a nav bar that goes back. So that's the user interface. That's a base. I think this alone is the basic interface for the app. Now we have to think about the back-end details. So let's think about those back-end details, right? What is actually happening in the background here? Okay, let's think about that for a second. Okay, so let me tell you what's happening here. We have this model. It's called BioBERT, right? And what you do is you give it an input, and the input is your ailment, and it will give you an output, which is a diagnosis. So let's think about this whole process that you do with the doctor in terms of data science. What is a data science pipeline? Well, you're giving a doctor certain features, right? What are you giving a doctor? You're giving a doctor feature 1, your symptoms, and then you're giving a doctor feature 2, which are not just your symptoms, but your medications, any medications you're taking, right? So medications. And you're also giving a doctor another feature, which is the side effects that you have specifically to those medications, your specific biochemical meat mass and how it reacts to these medications. So we'll say that this is side effects. So these are the 3 features that are input into this model, BioBERT, and it's going to output 2 things. 1, it's going to output a diagnosis, and 2, like, what is your ailment? Maybe it's, strep throat or something. And the second is going to be the treatment plan. So treatment plan. Okay, so that's how this model works. That's the black box of BERT. So what does this look like for us? So if a user types in anything, we need to understand what parts of, what are the keywords that a user is typing. We need to understand what a user is typing. We need to understand if a sentence contains symptoms, whether it contains medications, whether it contains side effects. So what we can do is we can create some logic here, which says, we'll hear the input. So let's just say, let's call that first input text. And so if text contains, this is pseudocode, by the way. If the text contains, symptoms, then ask, just like hard code, we're going to hard code this, by the way, because I'll tell you why in a second. So if the text contains some symptoms, ask other symptoms. If the text contains, and we'll do the same for each of these. If the text contains medications, the flow is actually, there's a lot of edge cases here, so let me just talk through this. If the text contains symptoms, ask any other symptoms to just include all of those symptoms. If the text contains medications, ask about side effects. If the text, and if we have all 3, if we have symptoms, medications, and side effects, then we can provide the output. So recall from that model that I showed you in the collab, recall that it required all of that as one input. So what we're actually doing here is we are creating a concatenated input for our model. So, none of this is actually BERT. This is just us doing this client side using just, a standard canned questions. Because what we're trying to do is take all this data and create one giant input to the model, get that response, right? So we're going to use text-to-speech to ask these questions. So you might be thinking, well, how do we know what a symptom is, what a medication is, what a side effect is? And the answer is we're going to have to use keyword recognition to know what each of these are, right? So there exist databases out there of all possible symptoms, of all possible medications, of all possible side effects to those medications, and we can do that. So that could be version 2 of our app, because adding keyword recognition is quite a challenging task on top of everything else we're doing. Integrating BioBERT is going to be quite hard here. But that's something that we would want eventually, okay? So, but until then, we'll just ask these 3 questions, hope and pray that all of these 3 are present in a user's input, get that output, and once we get that output, then we return it back to the model as a response. Okay, so that's the basic idea here. Right, so symptoms, BERT, that goes in the back end. Diagnosis and treatment plan is what we want. And then, we could think about other things here, like, depending on what the diagnosis is, send them to a different link to a different site like WebMD or something, etc. Things like that. Okay, so that's the basic app design. Let's get to coding. Okay, so we're gonna build this app in Flutter. And if you don't know, Flutter is amazing. iOS and Android, one code base, and it deploys to both platforms. It's got hot reload, quick rendering. Google should, be paying me for evangelizing this, but that's okay. We can talk, Google. I know you're watching. Let's talk. We need to rekindle our relationship. Amazon has been talking to me. We got to talk as well. All right. Let's become closer friends. So by the way, so how are we going to build this? Let's think about this for a second. We want to build an app that has those features. We're not going to find a Flutter app that has BioBERT integrated in it, but what can we find a Flutter app with? And I say this because BioBERT and Flutter are both very new. We could find an app in Flutter that integrates voice recognition, right? That would be great. And not just voice recognition. If it had that table view, that would be great too. So what I did was I found an app that does this. So let's look at this app. It's called Citidi. I'm mispronouncing it, but it's called Citidi, and it was created by Eric Gomez from Lyon, France. Hello, Eric. Thank you for this. So he open sourced this app, and it's a Flutter speech to text to do app. And it basically does that functionality for us. You say something, and in fact, he's got a video demo right here, which we can see. Okay, he opens the app. Ooh, he has it in French as well, and English and Russian and Italian.
Buy some milk.
Buy some milk. Great. And you just keep adding those. So what we can do is we can turn that into a chat window. Remember, GitHub is an incredible place for uncaptured value that we can turn into businesses. These are tools that are open source, freely available, but not many people understand the complexity of these tools and how they work, but you do. And that's what I'm trying to show you, how to do this. So let's continue with this. So let's go ahead and download this app together and run it to see if we can run it ourselves. All right, so let's do this. So what are the instructions? CD into it and just run Flutter run. That's super easy. We can do that. So I'll open up terminal. Let's make this bigger. Okay. Okay, I'm in it. Now I run Flutter run. And that's going to install all those dependencies and everything that is necessary. Okay, so it looks like there's a problem with something called Jack, which this thing requires. Okay, so now it finally showed up. So what I had to do to make it work was I had to add this Jack options enabled equals true in the default config for the Android build.gradle that you see this file right here in app for under the Android folder, under app in build.gradle. You have to add Jack options enabled true inside of default config. What is that? It's for some older version of Android to make sure debugging is proper. I don't know exactly. It doesn't matter. But the result is that it works. Hello, does this work? Yes. Hello, 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 hello. Okay. Clearly, voice recognition needs to be better, but it works. Okay, so now that we have a working app, let's examine what it looks like. Let's analyze it so we can build off of it, right? We need to know what it is we're building off of. So let's look at these files. Now it's got a file for Android and iOS, but what we have to consider is only what's in this lib folder, the library, and these are all the Dart files. Okay, so we'll go through these one by one, these Dart files, to see what each of their purpose is. So let's start at main. So main runs the entire app, and the widget, the entire app is a widget itself. The Citidi app, that is a widget, and that's the only code. That's the highest level. Now let's go down one level. So inside of Citidi app, it creates a class, and inside that class, it is drawing exactly what we're seeing right here. Okay, so it's drawing what we see right here. So what I can do is I can actually change this to hello world, it's Siraj, and hit save, hot reload. As you see it right there, that is what changes right there. See, hello world, it's Siraj. Now we have that, okay? So this code is drawing what we're seeing on this page. It draws the navigation bar and it draws the list view, okay? So that's that next step. Let's keep going here, okay? So we have that Citidi app. Now we want to understand the transcriptor, okay? So if we look at what it's implementing, it's importing transcriptor. Now what is happening here? The body of this list view is a transcriptor itself. So let's see what's inside this transcriptor widget. Okay, so it implements the recognizer, transcription, and task creation in the list view. So what it does is it implements all of those recognition capabilities that we need in a single file. So these are cases: on speech availability, on speech, on recognition started. Now we'll talk about this in a second, but we have to build a channel to be able to access this. You'll see what I mean, but we have to build something called a channel to be able to access these native features for iOS and Android. It's actually super easy, so I'll show you how that works. But once we built these channels, we can pull data to and from these native engines. Okay, so transcription, that's what it does. It's turning our speech into text itself. Now the task is just an object. Each of those widgets inside of that list, each of those are a task. And we can change the task to contain different parameters, a diagnosis, links to other websites, things like that. We can highlight certain words that are valuable, things like that. For languages, it's just a bunch of constant strings for all the different languages this is available in, which is great. And we can add more languages as well. And lastly, for Recognizer, this is the last app that we have. Now, this is where some of the magic happens. And we'll talk about this in a second, but basically, this is an interface to speak to iOS and Android distinctly, and we'll talk about that in a second. Okay, so that's the high level of what all 5 of these class files do, and now we can build off of it. So let's see what our next step is going to be. Our next step is to add a login and sign up page. So let's do that, okay? So we have this main page, but now we want to add a login and sign up page. How do we do that? And so the way we're going to build that login and sign up page is to look at the login and sign up page that I just built last week in my healthcare video. That's the great thing about code, is it's reusable. You can just reuse the same code in different scenarios and tack on other types of functionality to that code. So inside of this home.dart code, I'm pretty sure it was in here. I had this like login page. Yeah, here it is. So it was a login button and a sign up button, right? Yep, that's it right there. So we'll just basically copy and paste this login page right here inside of the scaffold. Okay, so it's got an image, the asset, the app logo. Let's just go through this for a second. This has got the image, the logo, and then the title of the app. And we're just going down as a column, top to bottom. Think about this as a design, right? Visual design. Underneath that, we have our container. Inside the container is the login button, before that are the text fields, the username, password, and then login. And then underneath that, there's a sign up button. And when they're pressed, they go to different events. So we can just copy and paste this and put it into our app. Okay, and once it's pasted in there, I now have a login page. Very simple stuff. And now that's it, right? So, and what I did for this login page is for this login button, I basically said on pressed, run app, new Citity app. So it's a super hacky way to navigate between a stateful widget and a stateless widget. And the difference between these is that one of them is mutable and one of them is immutable in terms of what data can modify it. One is dynamic and one isn't. And I'm going to figure out how to do this in a less hacky way later, but right now, when the login button is pressed, then it moves on to that next view. Okay, just like that. So just to reiterate, what I've done here is I've said, here's the background color. We have our own we have our own logo, our own title, etc., things like that. And that's the login page. So we added that to the existing app. Now that we've done that, what is our next step? Our next step is to understand how Flutter voice recognition works by building a plugin for this. So it turns out that this same guy who made this app, super cool guy, he also made a plugin for this on the Flutter plugin website. So if we go here to see all the things they have, all the plugins, we'll type in speech recognition, and it turns out that he just made this, which is amazing. And the app we're using is his example app. So when it comes to installing this plugin, we do 3 things. This works for all Flutter plugins. Add speech recognition to the dependencies list in the pubspec.yaml, which is right here. And then install it with Flutter pubget and import it just like that. We're going to build a very simple plugin because this already has that integrated. So we're going to take this opportunity to build a simple Flutter plugin that does one thing. What it does is it pulls data from the host device, the version of that device. And this is just a way to help you understand how plugins work. And so in order to do this, we need to, first of all, open a channel from Dart. So think of it as like we're at Dart and we want to go down to the iOS or Android level. How do we do that? Well, there's two ways we can do that. The first way is to implement what's called a method channel. And what that does is it lets you take a function and pass it down to the host. The second way is to create a basic message channel. These are both functions that allows us to pass data down back to the host. Okay, so basically, all channels do is they're a stream that allows you to send serialized data back and forth between the host and Dart. That's it. Okay, so how do we create a plugin? So step one is to create the package like this. Okay, so I'll just basically paste in this code from them. Okay, and so that's going to create the plugin. And so now it creates this hello folder. So I go to cd hello, and inside of that folder, I'll open it up, and there's going to be a folder called lib, and inside of lib, there's going to be hello.dart. Okay, so by the way, I need to add Dart to Sublime, but for now, we'll just add Go because it's kind of similar. Google languages. And then we'll implement the package, and then we'll develop the plugin. Da, 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 da. Makes sense. Oh, I see. So we actually need to have more than just the Dart code. So we'll say this. All done. Okay, so great. It's got an Android file, and it's got an iOS file, and it's got a Dart file. So if I go to helloplugin.m and .java, so basically these are the Java files and the iOS file, the Objective-C files. And then I'm going to have my hello.dart file. So here's what happens, okay? So I have this code right here. I actually wrote it down, but let me show you what I mean here. So I'll just type out the first part just so you can see me type something, because it's always nice to add some typing into these kind of demos. So for Dart, what we want is just these two lines right here. So just for Dart, I'm going to say static constant method channel. And then that's a channel. And you just have to, this is just how you instantiate an object in Dart. And we're going to call it plugin demo. And then that's that. And one more line, string version. So the platform version, await, because we want this to be asynchronous on the channel, invoke the method get platform version. Okay, so that's it for the Dart code. Now that's for the Dart code, and then for the Swift code, we say, okay, this is what we're listening for. This is the channel we're listening for, plugin demo. Now what I want you to do is to send this up from iOS. So it's using a native iOS UI device.current.system version method to get that version and send it back up via the channel to Dart. Now we do the same thing in Java, where we say, get the method channel, remember the name of it, what is it called? It's called the get platform version, and then it's going to send it right back up. Okay, so that's what's happening. Get platform version is there, get platform version is here, and then it's going to send it back up along that channel. All right, so, and right, get platform version is the code by which all these platforms are accessing this data, right? That's the one singular key that the value is then pulled from. Okay, so that's the identifier. Then once we've added the Java code, the Swift code, and the Dart code, all we have to do is say Flutter pub publish, and then it's going to publish it to that website that we saw right there. Right here, I'm not going to publish this because it's a test plugin, but basically that's the idea, right? So okay, so I wanted to explain that. Now let's look at, okay, so that might have been a little confusing, I understand. There's quite a lot happening, but now let's go into the details of how that plugin works for this specific app, for voice recognition. So inside of this app, what it did was inside of the recognizer, it built this interface that was able to, it created a method channel called recognizer, okay? And then it created methods for each of these activities. So these activate, start, cancel, stop, these are all signals that come from the host device when you're using those native APIs to perform voice recognition. So these are basically event listeners, right? Whenever something has been activated or started or stopped or canceled, send a message back up to Dart start to then, perform any kind of updates to the UI or whatever we need. And so that's that recognizer. So where is the recognizer being implemented? Well, notice that it's being imported inside of transcriptor, and inside of transcriptor, it's saying right here. So it's saying in the case that you hear speech availability or on speech or on recognition started, do these things. And so this has been able to create these channels, and attached to those channels are specific code snippets for Java and for iOS. And what we're able to do when we download this guy's plugin is we're able to use his Dart interface to access the Objective-C or Swift and Android code that he wrote specifically, but through Dart. So we don't have to do that. So that was just to show you the ideation that goes into building a plugin, but all you actually have to do is this, right? Here's the usage. Create a new speech recognition object and then set it to start listening just like that. But what's happening under the hood is it's accessing iOS and Android using those native languages, okay? Now that we have done that, let's go on to the next step, explaining BERT. Okay, so before I explain BERT, let me just quickly rap about it because I have to. You know me, I gotta rap, so here we go. I keep it lexical. When I train my BERT, intellectual. When I train my BERT, it's contextual. When I train my BERT, when I train my BERT. All right, I hope you enjoyed that rap about BERT. Now let's talk about the details. I need to get you a little hype. It's a little bit of the way through the video, so gotta keep you hype. You know what I mean? Okay, so for BERT is incredible. Seriously, oh my God. BERT is amazing. It is truly, truly amazing. So when Google released BERT, it was akin to the ImageNet moment in computer vision. The ImageNet moment was someone created this giant pre-trained model for image classification that other people could then reuse for other downstream tasks, whether it be image classification, image segmentation, all sorts of image-related tasks, right? Because it was pre-trained. Now not everybody had to take hundreds of thousands of images and train it themselves. They could build off of somebody else's work. And that's what BERT is for natural language processing. So anything you want to do with language, sentiment analysis, question answering, text summarization, there's a lot of tasks in NLP, text classification, text generation, everything. You can build off of BERT, which means you have less training time and it's more robust. And BERT stands for Bidirectional Encoder Representations of Transformers. A lot of words, a lot of terminology. If you want to learn more about it, watch my video on it. It's called Natural Language Processing, and it is on YouTube right there, Natural Language Processing. But it goes into BERT in detail. But basically, it's a transformer network, which has now replaced all variants of recurrent neural networks for sequence, let me be clear about this, for sequence classification and, frankly, for sequence generation. OpenAI uses it as well. They use something called GPT-2. All of these are models trained on lots of text in an unsupervised way, but BERT is my favorite one. But basically, and it was made by Google. But there's also Elmo, which Fast.ai released as well. There's a lot. But my point here is that let's just focus on one right now. BERT lets you do all of these NLP tasks super easily. Basically, you can think of it this way at a high level. Import BERT, BERT.retrain on my small data set of whatever task, let's say, detecting Teletubbies or something, and then immediately train super fast. That's the idea behind BERT. Instead of, if I want to detect Teletubbies, now I have to learn how to detect everything else and all that. Nope, already done for you. So BERT is amazing. So it's a transformer architecture, which is a sequence-to-sequence encoder, decoder architecture. Again, lots of terminology, watch that video. But the bidirectional part means that, let's say you use the phrase, I access the bank account. Sometimes any kind of language model will say, oh, bank like the river bank, or bank like you store it in your bank account, right? It depends on the context. So bidirectional means it does two passes across the sentence, both in one direction forward and another direction backwards. So it takes I access the and account into consideration when trying to classify the word bank, which is useful. It makes it better in terms of recognition because all of the context matters. That's the bidirectional part. I talked about the transformer part, and there's the encoder representation part, which is BERT was trained on millions of words from Wikipedia in an unsupervised manner. And the reason it did this is because the whole point of it was to develop these representations of data, right? So there's a lot of different variants of the word dog, dog, canine, animal, mammal, a lot of them. But after training on all this text supervised over time, it learns the essence of what a dog is. And so whatever word you say, as it will be able to compute the semantic similarity between that word and the idea, the thought of what a dog is. And so we can take these vectors, these thought vectors, also called encoder representations, and use them for all these objects as the starting point for a model trained on a specific task for us, in our case, of biomedical data. So that's where BioBERT comes in. And so I found this link to BioBERT. Good job, Korea University. Truly, we live in a global society. This came from Korea, which is awesome. But BERT came from Google, which is on the west coast of the United States. It just goes to show research is happening everywhere. And so this was released 6 months ago. Very, it's very new. But they retrained BERT on biomedical text data. Super useful stuff. And so then I was like, great, let me use BioBERT. Okay, what they did was they took those encoders and they input them and they added PubMed data and PMC data. But then I was like, okay, I might as well use BioBERT. But I actually found this other model. This is the rate of improvement that is happening in terms of AI. And look how new this repository is. It's called DocProduct, and that's that collab that I showed you at the beginning of this video. DocProduct is that collab right here where you could just talk to your model in real time and it'll say whatever your problem is, right? Let me just demo it one more time because it's hilarious. I love being alone. Let's try something weird one more time. I love being alone. I hate people. I don't know. It's some psychological problem. I love being alone. I hate people, and I like eggs. I don't know, that's not gonna make sense. Let's make it make sense. I love being alone and I hate people. How can I be more social? So this is like on the edge of medicine. This is like sociology and psychiatry, but let's just see how good it is. Sociopathy, psychopathy, you're not mentally ill, you may have PTSD. It could be the case. I mean, that's kind of a stretch, but you never know. Talks about how to make friends, being social is a skill, you have to learn it. It's very brave, to have some work. So it's actually got kind of good advice. That's crazy. This thing is incredible, okay? So my point is that this model right here, DocProduct, is what I use as a starting point for my model, not BioBERT. But basically what they did was they said, let me just show you exactly what happened here. So now for the last learning objective, how to use different models to get a more robust result. They found that BioBERT was great for question answering, but it could have been even better. So what they did was they broke down, they created a data set, first of all, from PubMed and all of these question and answer sites between patients and medical professionals. They split them up into separate data sets. Okay, and so you've got your questions and you've got your answers. Both of them are fed separately into the same BERT model. So it's got shared weights, but both are fed separately. And the reason they're fed separately is because when they're fed in separately, you create these embeddings. These are matrices of values that represent both the questions and the answers for each. Okay, so those weights, it goes through those weights and out come these embeddings, these collection of numbers that represent both the questions and answers. Then they input them both through another fully connected neural network, FCNN. Now, the reason they did this was to get these similarity question embeddings. And so what happened was that by inputting these embeddings into another network, the result was more robust. And so that's why they added another network. They could have not, but they found through trial and error that taking the results from BERT and inputting them to another network to create another matrix actually improved the results. And then what they did was they said, okay, let's perform the dot product between both of these matrices, both the question embeddings and the answer embeddings. And then they applied a softmax function. This is the same type of function across every single value. And they had the ground truth. Okay, so the ground truth was to see how closely a question related with an answer, right? Because some questions have proper answers and some don't. And so that's a 1 or 0, it's a binary result. Those are the labels. They found the error value between the outputs from the softmax, so the output of both models concatenated together, and they've compared that to the difference with the ground truth matrix, which are the labels, and then they they took that error value and they used the cross entropy loss. So they took the result of that and they performed backpropagation by updating the fully connected network and the BERT network. And I want to say there was one BERT network and there was one fully connected network. The reason it looks like two is because they want to show that both these inputs are input separately into the model. Okay, so how do we actually integrate this thing into our app? Well, it turns out that Tensorflow has this TensorFlow-like converter, okay? And so here's how it works. You import it like this. You say the converter equals, and you take that H5 file that was saved from Keras, and you convert it into a TF-Lite file, just like that. In 3 lines of code, you can convert something in Python from a Keras or TensorFlow, standard TensorFlow format into a TensorFlow-Lite format, tf.lite. And this is a great tutorial on how to do that in detail, but basically, if we go back to my previous video, how to build a healthcare startup, there was this TF-Lite integration that was already in there in this repository. I'll search for TF-Lite, and it's in Home. So I'll go to TF-Lite, and I'll search. There we go. So right here, remember, in this app, I could load up all of these image classification models as TF-Lite files. And so what I can do is I can reuse this code, but this time not to load a YOLO, or a MobileNet file, but that DocProduct BioBERT model, right? So in Python, what I'll do is I'll modify this existing Colab notebook that's already got the trained model right here. I have a link for you in the video description, and I'll convert it into a TF-Lite file, and then I'll import it into my Dart app using that TF-Lite integration with Flutter, and then I'll use it from there. So I'll serve it from there, but it's all right here. Everything is saved right here. Okay, so BioBERT, etc., all this data, and the index, the checkpoints, all that JSON, everything is there. But then it comes to the actual symptoms and talking to the doctor, right? Talking to the app itself. So what I thought I could do is we could say, let's create an array and then have these standard canned responses where we say, any other symptoms, any other medications you're taking, et cetera, things like that. And what we'll do is we'll say, okay, based on these symptoms and medications, we'll feed it to the model. So what I've done here is I've implemented my own tasks. Now, the hacky way is to create a timer that asks these canned responses. And so I've created a timer and then it just implements these tasks. But the better way is to, instead of pulling it from nowhere, pull it from the app itself. So once we've integrated TF-Lite into the app, then we can take that output, which is going to be a string, and then parse it, however we want. And that's, V2, V3, to be able to give that proper output. But this just goes to show that it is possible. It is very doable. All the tools, the guidelines, the instructions, everything you need is in the code in the video description for this video tutorial. All right, so that's that part. And now, that's not the only thing. There's more actually. We can add named entity recognition for the symptoms. We can add in different types of voices. We can add in more animations, make the interface better. We can add a continuous training pipeline that feeds data gained from the user back in somehow. And we'll talk about that later. We can talk about edge cases. What if someone says, I love, pillows? That has nothing to do with medical apps. So we want to have those edge cases fully defined. If they don't contain those keywords like symptoms, medications, or side effects, delete it. And then also we can have affiliate deals with drug companies, whereas, we have a certain drug we want to offer people, and we can have some kind of referral code and we can sell it through them. And that's another way to add another revenue source to our business. All right. But basically, these are the building blocks for your business. The code is in the video description. I hope you found this video useful. And if you like this video, don't forget to hit subscribe to stay updated when I release new ones.